inside of GitHub, this is actually using Launchpad. There you have it. So, but in any event, although all similar products there, but in any event, the big point that I want to make is if you are looking for some bit of functionality, I promise you it's out there. All that you have to do is just kind of go look, and you'll be able to find it. Promise. All right. Let's close all of this out, taking a look at the other part of date time, which is
the time.
There you go. What about times? Well, you're going to notice date time. So yes, it can in fact store times. There we go. So if we go in, we say date time .now, you're going to notice that I could go in, grab the hour, grab the minute, grab the second to go in and print all of that out. And you'll also notice that there's a whole bunch of different format strings that are available. Remember again, strftime.org will show you all of those that are available. I'm not going to sit here and just keep reading them all to you.
You wouldn't memorize them anyway.
Well, yeah.
There's no point. You look them up when you need them.
Exactly. And me reading them, I would just wind up putting people to sleep. Yeah.
And it's late in India right now.
Exactly,
so
yeah. It's late a lot of places right now, yeah. Okay, so let's just kind of go back to my little code. I'm just going to comment that bottom part out again. Control K, Control C, Control K, Control C.
Yep.
Comment. I'm just going to sneak back up here, and I'm just going to say print current date, and let's go in and say current date dot day or dot minutes.
Okay.
There we go. And hold on one second, because I think I'm going to be wrong up here. There we go. I want now, not just today.
Yeah,
I want now.
Okay.
So now, let me go back in.
Do you want to go just double check that syntax on the slide?
There we go.
Okay.
Nope,
I'm
just good.
Missing a close. We were talking earlier about closing
Have
double
some
brackets.
faith.
All right.
And now, have some faith, and I still blew it. But that's okay. So let me do this. I've got all sorts of funny things going on here.
I wasn't quite sure why you had that extra date in there.
There we go. And I'm still missing something. That's all right. You know what I'm going to do? You know why? Because I had started going one direction, and I just sort of went a different direction with all of that. But
that's fine.
Yeah, but in any event, and I'm just going to leave that there at the moment. But what you're going to notice there is that we could go in, use the date time like that. We could also go back in and go grab our hour, our minute.
We have properties. We have properties just like we did with dates. We could use string of time, just like we did with dates. The only difference is we're dealing with the times.
Exactly. Yep. So there's our little minute, and then away we go from there. So you can go in and go grab all of that, and there it is. Okay. So dates times. Again, here's the thing. You are going to find yourself working with date times on a regular basis. And yes, as we've seen, working with date times, again, not difficult.
It's fiddly.
It's fiddly. It's a little funky. It's a little bit can be a little quirky at times. The biggest thing that I really want to have gotten across here is sort of three things. Number one is the fact that we do have date time.
Yes.
Number two, the basics of how to go in and play around with date times, how to accept user input, how to do a little bit of math, a little bit of display functionality. And then finally, last but not least, number three, and this is the biggest point, and it's a point that I know I've made over and over and over again today, but it really is that important. Whatever it is that you're going to be looking to do, somebody else has done it. There are utilities that are out there. Don't be afraid to go grab them. That we talked about the date util. We talked about localization utilities. We talked about the function strings. Go take a look at all of those. Go use those to help make your life easier. Okay, so with that, I have a challenge.
All right, and this one, be prepared. You've seen us struggling with the formats of this one, so this one's going to be a little more difficult for you because you're going to have to deal with some of the formatting issues.
So what you want to do, ask your user, give you a deadline, figure out how many days it is that they're going to have. Maybe also go ahead and give it to them in some combination of like weeks and days.
So I would suggest, first of all, just try and solve it so it tells them how many days they have to complete the project.
Yep.
Once you get that working, then you say, all right, bring it on. Now I'm going to break it down and give it to them as days and hours or days and minutes and things like that. So break it down. But I would suggest get the first part working and then go to the next level.
Yep. Cool. Well, with that, what do you say we take 10 minutes?
Yep.
And then we'll come on back, depending on something. I was trying to get a segue. I was trying to get a joke there, and it failed. We're going to talk about if statements, which is all about we're going to do one thing if something is true. So depending on this, we're going to do. Anyway.
You were just trying to be clever. We'll be back in about 10 minutes.
There we go.
We'll
be back in about 10 minutes. All right. We'll see you then. So I says to the guy with the monk, oh, we're on.
Oh, we're live. Yeah, sorry.
Yeah, sorry.
Back.
All right. Hi. So, welcome back. Now, for those of you who may have missed it earlier, where have you been? No, for those of you who are just tuning in, that is Susan Ibach. I am Christopher Harrison. This is Introduction to Programming Using Python. And so far today, we've actually seen a lot of core components to programming in general, and then, of course, specifically in Python. We've played around with strings. We've played around with numbers. We've played around with date types. Now it's time to start adding a little bit of logic to our code, adding in a little bit of branching, and we start off that by utilizing if statements.
Absolutely. When we start doing problem solving with code, one of the things that we're going to have to end up doing is helping our code make decisions, figure out when to do what. Otherwise, we're going to be very limited in the types of problems that we can solve. You know, every day in our normal lives, we're faced with decisions. We have to decide in the morning whether we're going to school or going to work. Am I going to drive or am I going to take the bus? We have to decide tonight, you know, when this is all done, you know, am I going to cook at home or am I going out for dinner?
Going out for dinner.
You know, I need a new PC. What laptop should I buy? So we're always being faced with all these different decisions we have to make. Surface?
Surface.
Yeah, Surfaces are sweet little devices, I got to say.
Yep.
And the choice we make, though, does depend on different conditions. Whether we decide to drive or take the bus might depend on what time is it. I mean, if I'm running late, I might have to take the car, or am I going to miss the bus? Or what's the price of gas? If the price of gas has gone up a lot, I'm more likely to take the bus. If I'm trying to decide, do I cook at home or do I go out for dinner? The kind of things I think about is, well, is there any food in the refrigerator? You know, those are kind of factors that make a difference. And, or am I broke? If I'm broke, I'm not going out for dinner. I better cook at home. What laptop should I buy? The kind of things I think about is, well, how much RAM do I need? How much power do I need? How much money do I want? And I know you do want touchscreen.
Yeah.
Once you go touchscreen, you're never going back. We actually had someone asking what are V's monitors touchscreen, and you've even noticed this even here.
Oh, yeah.
Leveraging touchscreen. It's funny how quickly you get used to it.
I never thought I would want it. Then, like, within a day and a half, I just go up to random monitors. Like, why isn't this touchscreen?
Yeah, you just end up leaving fingerprints all over your friends' monitors.
Exactly, yes. That's how you can tell I've been in your house. Yes. Fingerprints on your monitor.
So there are a lot of different conditions, though, that affect what decisions we're going to make. And if you want to be able to write code that's going to solve problems, your code is going to have to make decisions as well. So let's say you're working at a bank. One of the rules they have at a lot of banks in North America is they'll waive the transaction fees if you maintain a balance of over $1,000. So if you were writing a program, it has to calculate what fees do I charge a user. You need to be able to say, well, if it's over $1,000, don't charge this fee. If it's under $1,000, charge the fee. Very simple, but very real world. If a user has canceled an appointment less than 24 hours before appointment time, a lot of times you still have to pay for the appointment. So again, if you were writing the program that was sending out bills, it would have to look at, well, what time did they cancel the appointment? If it was canceled a week ahead of time, don't charge them. If it was canceled within a day, charge them. And then I have to add a little Canadian reference here, right? My Twitter handle is Hockey Geek Girl. I am a Canadian, and I do love my hockey. So the other analogy I have is if a hockey player does get the puck in the net, then you add 1 to the score. If they miss the net, obviously you wouldn't do it. And you may be sitting there going, Susan, why would you ever write a program to do this? Well, hey, I could be creating a video game. There is Pygame, which helps you use Python for video game development. And you know what? If you've ever go to a hockey game, there is actually a sensor inside the net at the professional hockey games. And when the puck goes in there, the sensor detects it, and that triggers a little light to go flashing, and the little whing, that lovely horn noise that always goes off when someone scores a goal.
We're not going to do sound effects on that.
Yeah, that's never good. But that's code. It's saying if the puck goes in the net, then play this sound, light this light. That's code behind the scenes, what's happening. So there's tons of situations, real situations, where our code has to say, if this happens, do this. And that's what we want to get into here. So what we're going to do is we're going to use an if statement. So if we take a look at the code here, there's a few pieces of code here in terms of syntax. We start off, hopefully that first line of code looks familiar and isn't scary at all.
Yep.
All right, so I'm using an input statement to ask somebody to enter a value. I'm storing the value they give me into the variable answer. Now, so what do we do have as syntax, though, is we have an if statement. So we're saying if the answer they give us, I'll talk about this in a second, is yes, then print the following message. So without worrying too much about syntax just yet, basically we're saying if the answer is yes, print, that will be an extra $10. Because I'm saying, do you want express shipping? Yes, okay, then I'm going to charge you more.
It sounds actually relatively close to English, that essentially what you're saying is, if this is what I want, then do this.
Yeah. It really is.
If this is the state, do this.
Exactly. So now we understand the logic of it. Let's go back to the slide and take a look at the syntax behind it. So you have the keyword if that indicates we're looking at a condition. You have a colon at the end of the line. That is very specific to Python syntax. If you forget that colon, you're going to get weird little error messages appearing in your screen, and eventually you'll go, I forgot the colon. That's one of the ones I forget all the time. And then the other thing, and this is very significant, is the print statement is indented. That's how Python knows what's the command that I only execute if the answer is yes. If I say answer is no, and you have indented code, that code's not executed. So the indenting is crucial here because that's how Python knows what is the code you want me to run when the answer is yes. Now, if we go back again to the code, there's one last little piece I want to show you, and that is this double equal sign here. You'll see this in some other programming languages as well. In earlier code, we even have it on our previous line here, we use the equal sign to mean take this value, put it in here. So we say take the result of our input command, our input function, put it into the variable answer. So we're assigning answer the value returned by the input function. So the equal sign means take this value, put it here. So we can't use that in an if statement. It would be confusing.
Exactly, yeah. And that's really, it's sort of both for us, but it's also for the runtime as well, to understand the difference between an assignment where you're taking a value, putting it into a variable, and when you are trying to do a comparison.
Right.
Yeah.
So as a result, we end up with a special syntax. When we want to say if something is equal to something else, the double equals is the syntax for saying is equal to.
Yep.
So now if you look at this slide, we're saying if answer is equal to the string yes, then we have our colon, that's just part of a syntax, then print on the screen, that's going to be an extra $50.
Perfect.
So that's the syntax. Let's just look at a few examples so you can get a handle on it. We'll do a demo as well so you can start to get comfortable with it.
It's sort of funny watching the Q&A right now because there's now a little bit of hockey banter going back and forth. Go Ducks. Somebody said, we should make a dyno to set off the horn every time the Rangers score. Somebody else said that'd be a very quiet dyno.
Oh, man. And I'm sorry, speaking as a hockey geek girl, it's go Sens go. So I am a diehard Ottawa Senators fan. So, but not that I have any great hopes of winning the cup this year, but I am, for the record, go Sens go. So I showed you the double equal sign for is equal to. It's probably a good idea to talk about some of the other symbols you might need to use.
Yep.
Because sometimes you might want to say, is it not equal to? And that's another one where you just have to, this is one of those ones you will actually end up eventually memorizing it because you'll use these fairly frequently. Not equal to, the symbol for that is a exclamation mark followed by an equal. The exclamation mark is frequently used in programming languages to mean not. And that's why exclamation mark equals means is not equal to. So it's a convention that's been used in other programming languages. So the nice thing is, yeah, once you learn that syntax, you'll be able to use it elsewhere. Then if you go back to the slide, we can see a less than symbol. That's nice. It's the same as when we learned it in school.
Yep.
Greater than. One we didn't see necessarily when we're doing math in school is that less than or equal to. Because there certainly are times like, hey, wait a second, I said you don't pay service charges if you maintain a balance over $1,000.
Right.
But what if it's exactly $1,000? Do I have to pay the fees?
It's a good question.
It is. And is that a question the programmer answers?
No.
Yeah, this is one of the things you will run into in some situations. If it's your bank, you're defining the rule, and you're saying, well, no, it has to be over $1,000. So you have to have $1,000.01 to not pay transaction fees.
Right.
So this is actually something you will frequently need to double check on. And if you're writing code for someone else, you'll probably need to go ask them. Because they'll often say, oh, if it's over $100, if they make a purchase over $50, shipping is free. What if it's exactly $50? How do you want to handle that? Because you may discover if it's greater than or equal to $50, the user should not be charged for shipping or doesn't pay transaction fees. And the syntax for that, as you can see here, is greater than equal to or less than equal to. And there's some examples on the right-hand side of sort of what the code might look like.
Yep.
But I will say, we talk about making mistakes as coders. One of the most common mistakes we make as coders in if statements is less than should have been less than equal to, or greater than should have been greater than equal to. That is one of those. And it's one of those ones that the code works, but it doesn't do what it's supposed to do.
Yeah. Yep.
Yeah. We getting more hockey comments in the background
No,
there?
well, we are, but yeah. I was actually laughing. I was paying attention. I was listening to it, and I was laughing at that, because that really is one of the hitches in my delivery, that I frequently inverse the Boolean statements.
Yeah.
So, yeah.
Easily done.
Yep.
So here's another example of an if statement. And this is an example on the slide here. And what's significant about this is I want to point out the indenting here. So Christopher, do you want to take a guess here at if I ask somebody, would you like express shipping? And if they answer yes, I charge them an extra $10. Now, if they answer yes, do you think they're going to see that message, have a nice day?
I'm going to say yes, based on what you told me about tabs. And because of the fact that print is back on that first line, I'm going to say that yes, have a nice day is going to print.
And what if the person says, no, I don't want express shipping?
I'm going to go with the same thing because of the tab.
So all in all, so if somebody says, yes, I want express shipping, what do you think is going to appear on that screen?
Right. I think if somebody says yes, I think it's going to print out, that will be an extra $10. Have a nice day.
Right. And if they answer no?
Have a nice day.
Exactly. Because, and this is sort of where that indenting is so important to see, and I just wanted to illustrate that a little more clearly, that only if the answer is yes will the statement that's indented, or the statements, you could have multiple commands here, only then will those statements be executed. The code that you have that's not indented, doesn't matter if the if statement is true or not. Basically, it's going to ask the user for if they want express shipping. If they answer yes, it'll print the statement. But regardless of what they answer, it will continue executing the non-indented code, and everybody will see the message, have a nice day.
So if I wanted multiple lines to execute on that if, I would just need to keep tabbing them in to make sure that they're all there. Okay.
Exactly. Perfect. So you indent however many lines of code you need to execute. If answer is yes, you just make sure they're all indented. When you have a line of code that's not indented, it says, oh, that was all the code you wanted executed in that if statement. We're good. Now I just execute this code all the time.
I like it.
So the print statement being indented is essential. It's part of the Python syntax. Particularly important for if statements, and later on we'll see it with loops as well. All right, so let's take a look at that in terms of code, because you actually brought up an interesting scenario there, Christopher, of like, what if I do want things like multiple lines of code executed? So let's try that out. Whoops, cancel. Sorry, didn't mean to do that. All right, so let's go write some code. And what I'm going to do is I am going to say, let's see, favorite team, based on the conversations earlier, input, what is your favorite? And you know what? I'm gonna stir it up a little by adding a U to the word favorite, just for the Americans out there. All us British, Canadian spelling folks, Canadians are famous for inserting extra U's and everything. We even pronounce the word about as if it has an extra U. So I'm gonna include that there. What is your favorite hockey team? And then I'm gonna say if favorite team equals senators. Then I put my colon. And now one of the nice things is Visual Studio is smart enough that when you hit the Enter key after the colon, it automatically indents the next line. Because it's guessing you just wrote an if statement, chances are you want to now write the code, but only executes if the if statement is true.
Yep.
And if favorite team equals senators. Oh, and I've already got a typo.
Yep.
Before everybody starts throwing it into the comment window going, Susan, you've got a mistake. That should be equal. So if favorite team is equal to senators, and that requires the double equal.
Somebody else has already written one out for Blackhawks, by the way.
Awesome, very nice. Then I'm going to say, yeah, go Sens go. Go. And then I'm just going to say print. It's okay if you prefer football/soccer, because depending on the country, you may call it football, you may call it soccer or cricket or tennis or insert sport here.
Now, real quick, just to answer the question in the chat window, if we bring the code back up, right there, you've got if favorite team. By the way, you've got okay, you've got a small inconsistency. You said favorite on the display, but favorite on your variable name without the
okay,
but in any event, just to answer the question, that double quotes, that's checking a quality there. So single equals.
You mean the double equals?
Sorry, double equals. Double equals. The double equals is a quality. The double equals is a quality. Single is assignment.
Yes. So single means take this value, put it here. Double equal means is this equal to this?
Exactly. Yep. That's it.
You've got it. And yes, just to be consistent, I'm going to add an extra U to my variable names too, since you pointed it out.
Yep.
So if I run this code, and let's just slide it over so you can kind of follow the logic, and I enter Senators as my hockey team. Yep. Then it says, yeah, go Sens go, and it's okay if you prefer football or soccer. Whereas if you run this and you say Leafs, my son is a diehard Toronto Maple Leafs fan. It's a very tough life. They're not known as the top team in the hockey league. And I just say, well, it's okay if you prefer football or soccer, but it doesn't display the go Sens go.
Okay. Perfect.
And just because we were talking about what if you have multiple commands you want to execute, if a condition is true, I'm just going to add a second line of code here. And I'm going to say, but I miss Alfredsson. We had a tough time with my team. They traded away our captain last year, so we miss our old captain, Daniel Alfredsson. So anyone who would say favorite team Senators would know about Daniel Alfredsson. But if you don't know the Senators, well, that's not going to mean anything to you. So I'm only going to display that message if you say you like the Senators. So now, when I specify Senators as a team, it says, yeah, go Sens go, but I miss Alfie. And then again, so you can see all the lines of code that are indented are only executed when you specify Senators as a team.
Perfect. Okay.
Now, of course, there's one thing that eventually somebody's going to be going, but what if? Yep. What if I enter Senators in lowercase letters?
Only one way to find out.
Yeah. So, because you'll notice when I said if favorite team is equal to Senators, I put an uppercase S there. What happens if I type in lowercase? So is the string, and I'm going to ask you, the string Senators in lowercase letters, is that the same as a string Senators with an uppercase S?
Well, first thing this morning we learned was Python is case sensitive, so I'm going to say those are different strings.
Yeah, let's find out. And, oh, look at that. It comes back right away. It does not think my favorite team is the Senators. It is case sensitive.
And there's actually one other big thing that's worth pointing out here, since now we've done it the other way, is that you'll notice on the display that it just simply says, it's okay if you prefer football, soccer. It does not say either of those two tabbed in lines. It doesn't say anything about go Sens go, or in particular the second line, it does not say I miss Alfie, because of the fact that those were tabbed in. So you'll notice the tabs, again, make a big difference there.
Yeah, those tabs. And because they were tabbed in, those messages do not appear.
And a couple of people have mentioned, the tabs there is subtle. And absolutely, it is. But one big point that I would make here is this is actually a good habit to get into anyway, because there are a lot of other languages like VB where they're going to use an end if, or C#, which is going to use curly braces to denote the beginning and end, where technically that's what's going to figure out what's going to run if that happened to be true or not true. but you're still going to want to tab it in anyway just to make it more readable. So is it subtle? Absolutely, but it's still a very good habit to have gotten into anyway. So when you make the move to another programming language or to another programming language, you're going to have learned these good lessons.
Yeah.
So yeah, it is subtle, but yeah.
But at the same time, it's interesting. If you look at the code right now visually, what jumps out at you is, hey, there's some code here that's pushed over to the side.
Yep.
And it is very visual. A nice, simple way. The Python interpreter has to have a way of knowing what code do I execute only if statement is true. Yeah, you have to have brackets or something to tell it, stop here. But the indenting, it's actually a habit most of us do in other programming languages anyway. So they just said, let's just adopt what they're doing anyway and not make you write anything extra.
Exactly.
That's the way I like to think of it. It's just less work.
Yeah, there you go.
I'm a lazy coder. I like it.
And again, just to highlight, those do need to be tabs. You need to tab in.
Which it will do by default when you hit the enter key. But if you need to add extras, yes, that'll work.
Yep.
So that's your basic if statement. Now, I guess we should fix that, shouldn't we? Now, I'd left us sitting here hanging with a problem. Which is somebody typed lowercase and, didn't find a match. So we should really fix that.
Mm-hmm.
Now, if only there was a way we could use something to manipulate a string, because the problem is I have a string, and the user didn't enter it the way I expected them to. If only.
I remember doing a module on this.
On strings,
I remember
variables.
I was typing something in, like IntelliSense came up. That was cool.
So, exactly. We saw a number of functions we could use to convert values. So I could take, for example, the value for favorite team, and what if I converted that to uppercase? Mm-hmm. Right? Okay, now this is a funny one, and I've done this before to myself by accident. This is one of those silly mistakes. I told you I'm good at finding coding mistakes because I've made a lot of them. And here is an exact example of a piece of code I have written and run and beat my head against a wall going, why isn't this working? So take a look at this code for a second. I'll give you a second to read it. And see if you can spot Susan's mistake. I'm going to run it now. I'll leave the code up on the side so you can still look at it and see if you can see what I did wrong. And I type in senators, and it's going to convert that for me before it does the comparison. And then I enter senators, and it still says, hey, it's still not executing my if statement. Can you see what I did wrong? And I have done this.
Yep.
Go ahead, Christopher.
The problem is you've got senators with a capital S and lowercase after that.
Right. So I'm taking the value they type in for a hockey team, converting it to all uppercase letters, and saying, by the way, is senators all uppercase? Is the value they typed in all uppercase equal to this value that contains lowercase letters? And that's where I sort of sit there and go, oh my God, did I really just do that?
Yeah, you've hard-coded in a bug.
Yeah, so what I should really do here is this should be senators would be helpful.
Yep.
And now it should match, no matter how I type it in. Yay, success. Where I usually actually get caught with this isn't necessarily that I had the string senators. What often happened is somewhere earlier in my code, earlier in the day, I had written some other code early. Exactly. I had written a best team equals senators. And what I had was maybe I had something like it was up here somewhere else, and over here I said, oh, if favorite team equals best team, then go ahead and continue. And maybe this was even a value I read from a file somewhere where I couldn't even control the case. So maybe when I read this from a database or read this from a file, I don't know if what I read from the file was uppercase or lowercase. So I'm saying compare what they typed in to a value I read out of a database or out of a file. So now I'm saying, well, I want to convert it to uppercase so it's case insensitive, but now what I need to do is go back to the code, and I may need to actually say convert both sides to uppercase before comparing.
And that generally is the best way to approach this, that if you're going to say, I'm going to convert one side to be it uppercase, lowercase, or otherwise, convert the other side as well, so that way you know that it's always going to be that consistent casing, so you won't get stuck there. I would also mention that a couple of people mentioned about, well, you could use capital, you could use lower, and all of that is 100% true.
They will all work.
Yeah, as long as you call the same function on both sides, make sure that they're both cased the same way, it'll work.
Yeah. For some reason, upper seems to be the more popular choice.
Yeah.
But there's absolutely, it would work with lower. It would work with the initial capitalization function as well. Yeah, just make
Exactly.
sure they're both the same casing.
Yep.
It does happen. That is one of my Susan's pet mistakes that I just make all the time. So I just wanted to share that one with you.
Yep.
One of the other things that's interesting about writing if statements, we learned about how you can write code different ways. If statements can often be expressed in different ways. If you look at this slide, I could say if the answer equals yes,